question number 2 wants us to find the partial fraction decomposition of the rational function. So partial fraction decomposition is the inverse operation of adding and subtracting rational expressions. And if you have to take Calculus 2, then it's a very important step in some of the integration problems in that class. So looking at number 2, this is actually the answer that we got for number 1. So the answer that we should get for number 2 is actually going to be the question from number 1, because it's the reverse process. So how I do partial fraction decomposition problems are, I'm trying to figure out what were the original fractions that added together to get this. So it must have been something over x plus 2 plus something over x minus 3. So instead of just saying something, I'm going to call these A and B. My next step is I want to multiply everything by this denominator, because that's the LCD. So I want to multiply by x plus 2, x minus 3, x plus 2, x minus 3, and x plus 2, x minus 3. And if you don't want to write it next to each term every single time, you don't have to. One of the shorthand notations is to actually just put brackets or just a big parentheses around everything and just say I want to multiply everything by x plus 2, x minus 3. So if you do that, then that's going to cancel out with both of these terms here, and that'll leave you with 7x minus 1. With the a over x plus 2, that's going to cancel out with the x plus 2's and leave you with an x minus 3. And then on the third one, the x minus 3's are going to cancel out, and you're going to be left with an x plus 2. Okay, my next step is I want to distribute. And then my next step is I want to group my x terms. So on the right hand side, any term that has an x, I want to put those together, and then any term that doesn't have an x I'm going to put at the end. So I'm running out of space here. So the left hand side I'm not going to change, but that ax plus bx, I want to write those together. And then the negative 3a plus 2b I'm going to write together. And I'm doing this because I actually want to factor. And I'm going to put the other terms in parentheses, and I'll show why. So now we're going to do a process that's called equating coefficients, or equate coefficients. And what that means is, if you look at the left-hand side, we have an x and it's being multiplied by a 7. On the right we have an x and it's being multiplied by a plus b. Well, because this is an equation, those must be equal. So an x equation could be a plus b is equal to 7. And I can do the same thing with the constants. So on the left I have negative 1 as my constant. On my right, all of these I'm going to classify as the constant because they're not being multiplied by x. So I have negative 3a plus 2b is equal to negative 1. And so this is a process called equating coefficients. And what I've made now is a system of two equations with two variables. And I can solve that by using a matrix. If you do reduced row echelon form, you get a is equal to 3 and b is equal to 4. So my final answer will be 3 over x plus 2 plus 4 over x minus 3. So I'm putting the a and the b that I just found back into this template here. So these were the original two fractions that I added together to get 7x minus 1 over x plus 2 x minus 3. And again, if you did question number 1, you'll see that this was indeed our original problem.